Welcome to another lecture of Smart Pathshala. Today we are going to start another series of probability. Okay, now in this lesson we will learn some basics of probability. We'll start from the basic, and in that way we'll go to the syllabus of the CBSE class 12. So in this lecture 1 we'll read about what is probability in general language, then we'll see some terms related to it, which is the random experiment, then we'll see events, then we'll see sample space or event space, then we'll see what are called the mutually exclusive events, then we'll see impossible or certain events, and then we'll see some complementary events, then we'll see equally likely events, and like this we'll go on. Okay, now let's start with probability. Okay, now suppose the traditional way to start probability is to start with an experiment. Suppose you have an experiment of tossing a coin. So obviously if you are tossing one coin, a 1 rupee coin, then what you have is the outcome is either tails or the outcome is heads, right? So these are the two outcomes which you can get. Now if someone has asked that if the outcome is head, then India wins the toss. So what is the probability of getting that? Actually we calculate the probability by the number of sample space. That is, the total number of outcome is only the head and the tail. Now, if we have head only one times appearing in this set, so we will put 1 here, and then the sample space will be 2, the total number of sample space, right? Okay, now in this way we will come to define some terms related to probability. The first one is the random experiment. The random experiment means some experiment which are having the outcomes as random. Like you guys must have watched the movie that Sholay. Okay, so there you have seen that Jay always had a coin, and this whenever he used to toss it, it only revealed the head. Actually, in that coin, at the last of the movie, you can see that coin has both faced to be head. So that is not a random experiment. That is biased experiment, because whatever you can get out of the experiment is obviously a sure event, right? Now in the random experiment, you don't know whether it will appear heads or tails, or in case of a die, you are unable to predict surely that 100% that only 6 will appear when you will throw the die once. So that type of experiment is called the random experiment. So for example, like throwing a die, is a random experiment. So in this way there are many examples of random experiment, like pulling out one card out of 52 cards from a deck, right? Okay, now let's come to the event. Now from a random experiment we will have some outcome. Suppose if you throw a die, we'll have some numbers, like you can get 1, you can get 2, you can get 3. Similarly, you can get 4, you can get 5, you can get 6. Now, suppose you are playing the game of Ludo. In these lockdowns, the Ludo is so much famous, right? So you can predict what is the chance of you to win the game, right? Okay, applying probability obviously. Now, suppose the favorable condition for you is to get the event, that is, you have to get a number which is less than 4. Okay, now this number B is less than 4. So you have how many numbers? 1, 2, 3, right? So you have 3 numbers. So this definition of getting the terms, right? Getting the elements of the sample space is known as simple event. Okay, now compound event. What is a compound event? Suppose this compound event is such an event where you can decompose this as an event into 2 or more simple events. Okay, now suppose you have an event. This event of getting number less than 4 is A. We term it by A. Now suppose you have an event of B, which is getting a number 6. So if you have A union B, so that is actually a compound event. That is, either A occurs or B occurs, right? Now remember, this union and intersection, these both terms are very useful. This means sometimes or this means sometimes and. So be very careful while handling these terms. Now let us come to sample space or event space. A sample space is the number of outcomes that an experiment can give. Suppose you are tossing a coin now 2 times. So first time you toss the coin, you get tails or you can get head. Second time you toss, you can get tail as well as you can get head. Here also you can get tails and as well as head. So what are the outcomes? Tail and tail. This one can be outcome, and again tail and head. This one can be outcome. The third outcome is head and tail, and head follows. So this is known as the sample space. Remember, this is the biggest set of events that you can arrange from a random experiment. So now let's come to the mutually exclusive events. What are the mutually exclusive events? Suppose you have tossed one coin, right? And you are getting tails and heads, right? So now A is such an event of getting tail and B is such an event of getting head, right? So there is no chance of getting A and B. That is, you can't get tail and head simultaneously in only tossing the coin once, right? So in that case, we can write that A intersection B equal to null set, which means actually A intersection B will have no events in its favorable case. So if you do the probability of that, it will obviously be 0, right? So these types of events are known as mutually exclusive events. Also impossible and certain events. What are called impossible and certain events? So now suppose you have one Ludo die, okay? Now you have six of your coins, 1, 2, 3, 4, 5 and 6, and here is the end button, okay? Now you need 1, 2, 3, 4, 5 as well as 6 for getting at least one of your coins inside of this home, right? So in that case, either you get 1, 2, 3, 4, 5 or 6. All of these are at your favor, which means whatever you get out of this experiment, that will be in your favor. So in such case, these types of events are known as impossible events. Certain events are certain events, right? These are called certain events, which means if you do the probability of certain events, you will get 1. It is sure. Now for the impossible events, the probability of impossible events is obviously 0. That is, there is no possibility of getting such events. What are called complementary events? Now, suppose in tossing a coin, you have tails and head. Suppose A is such an event of getting tails and you have a half. Now suppose someone has asked you what is the probability of not getting a tail. Now we denote it by having a C as the index of A. So where you denote P of AC, which means P of, that is the probability of not getting the tails, or we can calculate this as 1 minus P of A, which means 1 minus half, so that is equal to half as well. And equally unlikely events. Equally unlikely events are like tails and heads of one coin toss, because in this case the probability of getting tail is half and the probability of getting head is also half. So since both of the probability of getting both events is equal, so these type of events are known as equally likely events. That is, they are equally likely to occur within a random experiment. Also, now let us come to the classical definition of the probability. Now here it is said that probability of A, which means number of equally likely event points contained in A, which means A is actually the user's favorable events, from an experiment, suppose a die experiment, you have this sample space of 1, 2, 3, 4, 5, 6. Yeah, only 6. Okay. Now A is such an event which consists of 1, 2, 3, 4, and 5. That is excluding 6. Okay. Now probability of A will be number of equally likely events point contained in A. So how many number of points are contained in A? Only 5. So you will put a 5 in the numerator. Similarly, you will put 6 in the denominator. That is the sample space. Now, odds in favor and odds against the event. Okay. Now suppose you are having an event A whose probability of getting is m by n. Okay. Now the ratio m is to n minus m is odds in favor. Okay. Now the reciprocal of this term, that is n minus m is to m, is odds in against of the event. Perfect. Now let us come to some important results that we obtained from the previous terms. Okay. Now the first thing is that the probability of a null event is 0. Obviously the null event means you don't have any equally and likely events within your favored condition. Okay. Now another formula is P of AC, that is probability of getting the complement of a certain event A, which is given by 1 minus P of A. Again, now this number 3. Okay. Let us prove the number 3. It says the probability of a certain event lies between 0 and 1. How can this be possible? Now remember the classical definition of probability. The classical definition of probability says that this probability is the ratio of number of equally likely event points contained in A by number of equally likely event points contained into the sample space. Now also consider the previous example. How many maximum number of points we can have in this set? We can obviously have 1, 2, 3, 4, 5, 6 number of equally likely event sets. So that is the maximum. That means if you put it in the equation, you can get a maximum value of 1 only. Similarly, you can get a minimum value of 0 by 6, which is 0. Then obviously the limit of P of A is obviously lies between 0 to 1. Okay. So the next property can be shown after showing some Venn diagrams. Let us say A, this is a sample space. Okay. If you denote this rectangle as a sample space and you have two events, this one is A, this one is B. Okay. Now this shaded region is nothing but A intersection B. Okay. Now suppose this is a sample space S. Now you need to find the region A. Okay. Now how can you find the region A? See, if you do this thing, A, okay, and then you need to subtract B. Okay. Okay, I am subtracting B. That means you are having now this much area, this one. Okay. Now that much area is divided. Now what you again need to add is that this section, obviously the common section is also belonging to A. So which means you are adding A intersection B as well. Okay. Now in that case, you can write A intersection B plus A minus B. Okay. Now how can you interpret this subtraction operation using set? This is impossible, right? So for denoting this term, we use another meaning. Suppose it have A minus B, then we can obviously write A intersection B complement. How can I write? Let's see. Suppose there is another Venn diagram and we are having A and B. A minus B is obviously you are getting this area, okay, the shaded area. Now what is the area that we get after putting this A intersection B complement? Now see, B complement is obviously the whole bunch of elements excluding B. Now A intersection B complement is the area that is having common between A and the B complement, which means you are getting the same amount of area which you got earlier by A minus B. Okay. Now in that way, if you put the probability, as probability is distributive over addition, so you can get the number fourth formula as well, right? Now in that way, we can write the another corollary of it, which means P of B is equal to A intersection of B plus P of B intersection A complement. Okay. Now let's see another formula, which means this is a very important formula. And also before this, you need to see some sets. Suppose this is a sample space. Okay. Now you are about to calculate A union B. Now P of A union B you have to calculate. You know P of A union B, right? Okay. Now A union B means the probability of getting A or B, right? Or B, not and B. If it was written as A intersection B, then it would have been probability of getting A and B, which means it is the probability of getting A as well as B, which means if only A exists, B does not exist, then you don't have any favorable condition. The favorable condition is only when the both are existing at a time. But in this case, in union case, if only one exists, then it's okay. If only both exist, then it's double okay, right? Now in here we have to find out. Now let's say what is A union B. We have to find out using Venn diagram. First we need to add this term. First we need to add A, okay, the whole area A, and then the whole area B. Okay. Now notice that this area, that is the A intersection B, the common area, is being added twice, right? So obviously you need to subtract the A union B once so that you can include the whole A union B. Now suppose you are getting the probability of A union B, and as probability is distributive over addition and subtraction as well, then you can get the probability like this. Hence you are getting a formula like that way. Now let's practice one problem. Suppose they have given this term, probability of A is half and probability of B is suppose 1/3, right? And probability of A union B, say 0.9, which means you can get 9/10. Now you need to find out probability of A intersection B, right? Generally these types of problems will be given in more vocabulary language, because you will be having one event A, another event B, then there will be a line which describes the chance of occurring A or B, and they will be asking the question like that. You will have to find out the probability of getting A and B both at a time, right? In that case, apply this formula, you will get the result like this. A union A intersection B is equal to P of A union B, which means you have 9/10 minus half minus 1/3, right? So in that case, you are getting 0.9 minus 0.5 minus 0.3, right? In that case, you are getting 0.4 minus 0.3, and that is obviously 0.1333, right? So this is the probability of getting A intersection B, right? Now for today, this has been the introduction of probability. For the next day, we will solve some basic problems of probability, and then we will go to describe the conditional probability. That is another breakthrough in the field of probability, and simultaneously we will study some other properties of probability function. Okay. Now for today, the lecture is over. See you in the next video.